Let's go over another example. So in this example, we want to check or verify that y equals to c x to the fourth, and also y equals to, well, here we're going to define it piecewise. If x is less than 0, then y is defined as negative x to the fourth. And if x is larger than or equal to 0, we're going to have x to the fourth. Our solution of the differential equation, well, x y prime minus 4y equal to 0. So as you can see, if these two are solutions of this differential equation, since this has constant c, we call it a family of solutions because we can change the values for x. And here you don't see any parameter. You don't see any c. Well, in this case, we call it a particular solution. So let us check to see if these two are solutions for this differential equation. Let us check y equals to c x to the fourth. So as you can see, we need the derivative of y. So y prime is equal to 4c x to the third. Now let us substitute. Here you have x times y prime, which is 4c x to the third, minus 4y, y is cx to the fourth. So of course, on this side, you have 4c x to the fourth minus 4c x to the fourth. They are opposite of each other. It's equal to 0, and it's equal to the right-hand side. So left-hand side and right-hand side are equal to each other. What's the meaning of that? It means that you have a family of solutions for this differential equation. So y equals to c x to the fourth is a family of solutions to the differential equation xy prime minus 4y equal to 0. Now let us check this particular solution. Y is defined as negative x to the fourth if x is less than 0, and if x is 0 or positive, we have x to the fourth itself. So let us start taking the derivative. Let us check y equals to this particular solution. If it satisfies the differential equation, we call it a particular solution because it doesn't have any parameter. So y prime is equal to the derivative negative 4 x to the third, the derivative for x to the third when x is less than 0, when x is larger than or equal to 0. Well, if you plug in negative 4x cubed into the derivative, you get negative 4x to the fourth minus 4 times y. But what is y? The y in this case is negative x to the fourth. They're going to cancel off each other, and it is 0. The same for the second part of this piecewise defined function. If you plug in 4x to the third, x times 4x to the third minus 4y, which is x to the fourth. Of course, they are opposite of each other, and it's equal to 0. By substitution, we see that y satisfies the differential equation. In this case, we say that, hey, y is a particular solution. So y is a particular solution of the differential equation. Why we say that it's particular solution? Because it doesn't have any parameter in it. So let's write this down here. Particular solution. It doesn't have any parameter. Let's see.